So hopefully today's nice and easy. This is our third day going over transformation of functions. So what we're looking at is we're going from a graph to the function notation itself. So we're skipping the verbal explanation, but it's still the same rules. Okay. So the only part that makes this a little bit difficult is if we haven't seen too many of the graphs, the stretches and compressions are a little bit hard to tell. So I'm going to say don't focus on that part there. Let's look at what we can determine just using our eyeballs without having to do any real calculations. So first off, we can tell what kind of function it is. Since this makes a v, it's an absolute function, so we should see absolute value, which does not help us at all. All of our answers are absolute functions. We move on. I see it's pointing down. So I know that's a reflection, so it should lead off with a negative sign, which again, doesn't help us at all. So they all have that. Okay. But then I see it's shifted to the right, which means part of my rule, it should be x minus h, right? So I'm looking for a minus sign inside the absolute value, and that eliminates answer choice B and answer choice A, okay? And then I see that it's shifted upwards, which tells me that if I have x minus h, I should also have plus k on the outside. So I'm looking for a positive number on the outside. There it is. That eliminates answer choice D. So all that is left is C there. So notice I didn't even have to look at, for some reason, why there is a vertical stretch and a horizontal compression happening at the same time. Don't worry about that. If you actually graph this, it won't look like this picture anyways. So I don't know why they did that, but that's what it is. So focus on what type of function is it? Is it reflected? And then is it shifted left to right or up and down? Okay, that'll get you through all these questions. Hopefully it's not too difficult. Okay. If you really say, Ellis, I want to know, I want to be able to do the stretch. Okay. What you can do, and this isn't perfect, so we're going to talk about slope, and quadratic equations and square root equations don't have slope the way you think of them. But if you start at your vertex, okay, for any of these, and if you go over by 1, so if x increases by 1, what is the change in 1? So for this one here is 2. That makes the slope just between those 2 points, just in this part of the equation, the slope of this is -2, or on the other side is +2. So don't really look at the sign for that, just consider the number. There's 2 here. So our stretch or compression, you should see a ×2 somewhere. Okay. But I'll tell you, you don't need to know that. You don't have to do this. You can answer all these questions just by knowing, what do we know? So I know this is absolute. I know this is flipped. And look, see that gave us the same information. Just because it's flipped, we also know it's going to be A or B. I didn't have to do all that extra work. It's not shifted left or right, so I shouldn't see a plus or minus inside the absolute value. So that eliminates answer choice A. But I do see that it shifted 1 unit up, so I should have a +1 on the outside. So you get answer B. So I didn't even need to know that this had a horizontal compression of 2. Okay, so again, don't worry so much about that. Focus on, is it reflected? Is it shifted left or right? Is it shifted up and down? And is it the correct function? And I don't think there's anywhere you have to actually know the difference. Most of these they're pretty much the same all the way through. Yeah, like the square root function, you'll see square roots on all of them. Oh, these are all square roots. Okay, so you can practice seeing what square roots look like. That's nice. And then all these are quadratic. If you want, because this won't take you that long. It's only 10 questions, I think. If you actually want to go to your favorite graphing calculator and you can check your answers, so whichever answer you think it is, type it out, and it should look fairly similar to what you see on the paper. Just Just don't graph this example one because it won't look like that and you might think that I'm wrong. But I promise you, as close to right as I can be. Okay, good luck. Ask me questions if you're still stuck.